In an earlier video, I showed you how to set up a Three.js component in Hype using JavaScript ES6 modules. This approach is useful because it divides the code for your 3D animation into small interacting parts and makes your project more manageable. This becomes progressively more important as your animation grows in size and complexity. In this video, I'll extend this example by customizing our existing modules and adding new ones. I'll start by demonstrating how to change the appearance of our initial cube. Then we'll look at how to transform its position and change its orientation in 3D space. Later, I'll add more complicated geometries to our 3D world by constructing new modules that incorporate additional Three.js shape primitives. And finally, we'll create an animation loop module to put these shapes into motion. Our final animation will look like this. Hopefully, the ease with which we make these changes will further accentuate the power of this modular approach. So, if that sounds interesting to you, let's start by considering the terminology Three.js uses to describe shapes. A Three.js shape is called a mesh. A mesh is composed of a geometry and a material. This mesh represents all the tiny triangles that are combined together to make a shape or an object. These meshes can represent simple objects like a sphere, a cube, or a flat surface. But they can also be more complicated shapes like a cat, a person, or even a building. Three.js has many built-in shapes, but you can also create your own custom geometries in other programs and load them as external files. A material represents the surface properties used to draw a geometry. This includes properties like its color and how the surface interacts with light. A material can also include one or more textures that represent its surface appearance. Three.js has many built-in geometries, and I've shown many of these in this animation. These geometries are called shape primitives and are generated at runtime using a bunch of default parameters. It's common to use primitives for things like a sphere when drawing a globe or a bunch of boxes when drawing a 3D graph. It's especially common to use these primitives to experiment and to get started with Three.js, and that's what we'll do here. Our initial cube used many of these defaults. For instance, unless you specify otherwise, every new shape is created at the center of your scene. A point that is often called the scene's origin. Some of these default properties were overridden in our initial example, things like the cube's color and its rotation in space. We did that in the Cube.js module. Let's dig into the code now and see how it works. Here is that code. Let's quickly highlight the important parts that you should try to understand. Firstly, the import statement on line 1 calls the parts of the base Three.js library responsible for generating the box geometry, the mesh, and the material that goes into making our cube. Next, line 3 creates our primary function, which I've called createCube. Most modules do a lot more than just define a single function. But remember, we're just getting started and things will get more complicated later. Line 4 defines our cube by generating a box geometry with a dimension of 2 for each side. The base unit in Three.js is meters, but in general, you don't need to worry about the absolute size of things, and therefore you can treat these as relative units. In line 6, I've defined a new material, and set its color property to purple. There are numerous material types in Three.js. The mesh standard material type is one of the simplest but is notable because it requires a light source in the scene to be visible. You can see this in the way our initial cube is lit on some surfaces while others are obviously in the shadows. Next, in line 8, we make the cube itself by creating a mesh that includes the geometry and material we just defined. Once we have this cube, we also have access to its properties so we can make changes to its appearance and position. We do that in line 10, which rotates the cube a little in 3D space. This slight rotation is just enough for us to distinguish it as a cube rather than just a flat square. And finally, on line 15, the cube creating code is exported from this module. Now, if we switch over to the world.js file, which is the module where we created our 3D world, you can see how we have imported this function from Cube.js. And then used it to create a new cube which is subsequently added to our scene. In our modular approach, each chunk of code like this is responsible for constructing and defining a single object. In this case, Cube.js defines a purple cube. But what if we want to make multiple cubes? Or cubes of different colors? At the moment, the color purple and the cube's dimensions are hard-coded into this function, so it can only make one kind of cube. What's more, we don't define all of the possible properties of the cube. For instance, we haven't specified the cube's position in 3D space, and therefore Three.js will place this cube at the scene origin. This isn't very useful. We want to be able to use this function to make multiple cubes of different sizes with different colors. And we want to be able to position them anywhere within the scene. We could do this by duplicating Cube.js and then specifying different colors and positions, but there is a better way than hard-coding things in this way, and that is by adding parameters to this function. Let's start by adding color as a parameter. Here's a revised version of Cube.js that I've refactored to allow different colors to be passed into the createCube function as a parameter. You can see how that parameter, I've called it color, is inserted into the parentheses that immediately follows the function name. Then, if you look inside the function, you can see how I've used that parameter to replace the code previously used to specify the cube's color. If we switch back to world.js, you can see that we now create a new cube by calling the createCube function with the color parameter defined. This change enables us to produce shapes of any color simply by passing in a color of our choice with this parameter. Let's prove this works by changing the color and rerunning our hype animation. I'll use the color red as an example. Now, you can see how we've produced a red cube instead of the original purple version. So far, we've specified color as a string using simple color names like purple or red. These strings must be surrounded by quotes to indicate they are a string. But we could equally well pass in hex values or even a hexadecimal literal. These kinds of values don't require quotes. Instead, they are hex values, 0 through F, preceded by a hashtag character. Describing colors in this way gives you a greater choice in the number of possibilities you can employ. At this stage, you're probably wondering, how do I add more than one cube to my Three.js world? And, do I need to make a new module, or can I reuse the one we just made? The short answer is yes, but we'll need to add some new parameters that specify size, color, and position first. We'll do that next. I've jumped ahead and refactored Cube.js more by adding additional parameters that define a cube size and position. The current version of our createCube function now looks like this. It has an expanded parameter list that now includes color, size, and position in 3D space. And instead of relying on the default values that Three.js creates, I've explicitly defined each of these properties directly in the createCube function. I've also made the corresponding changes to world.js, and we'll see those in the next section when we start to add new objects to our 3D world. You probably won't be surprised to learn that we add new cubes to our 3D world by calling the createCube function multiple times but with different parameters. You can see how I've done that here in world.js. I've added 3 additional cubes, each with a different surface color, and positioned them around the original purple cube. All of these cubes are added to the scene at the same time with this line of code. And this gives us a scene that looks like this. So adding new cubes was relatively straightforward, but what if we want to move beyond cubes and add different shapes to our 3D world? Well, we'll see how that's done next. Because each shape primitive in Three.js employs a specific geometry and requires us to use different parameter types to configure it, it makes sense for us to construct new shapes using independent modules. I've done that here by creating 3 new modules, one each for a sphere, a cylinder, and a cone, and I've added these new modules to the resource panel in Hype. And then, I've imported these modules into world.js and called them in precisely the same way as we did for Cube.js, just with different parameters. Now when we run this project in Hype, we get an animation that looks like this. Digging into this code, you can see that the underlying structure of these new modules is similar to Cube.js. For instance, when you compare Cone.js to Cube.js, they look almost identical except for the code parts that define each geometry, and the slightly different parameters used when it is called. So now, we have one last task to finish our animation, which is to set these shapes in motion. Let's do that now. Up to this point, our scene has been rendered only once each time we run our project. We did this using the renderer.render method at the end of the world.js module. This is a standard method from the base Three.js library. We gained access to this method in our project when we initially set up the renderer.js module. However, for us to see motion, we need a way to repeatedly render our scene over and over while changing the position of its shapes. We need to make 2 changes for this to happen. Firstly, we need to make a new module that re-renders our scene at regular intervals. We'll call this module loop.js. Inside loop.js, we need to create a function called setAnimationLoop that repeatedly calls the renderer.render method with each successive time interval. That function looks like this. While this function is looping, we'll incrementally rotate the position of each shape just a fraction. We'll achieve this by adding some further code to each shape module. For Cube.js, that code looks like this. Basically, this code works by causing small changes in a cube's rotation each time it's called. When we put these two changes together and run our project in Hype, we get our final animation, which looks like this. You'll notice I've added some additional grid lines to our sphere shape to make its rotation visible, and I've changed the color of the cylinder to better distinguish it from the background. And with that, our animation is finished. I hope you enjoyed this second introductory video and appreciate the power of using ES6 modules and Three.js together in Hype. I'm sure that you could probably construct a simpler example, but my goal here has been to describe an approach that scales as your project grows. Arranging things this way helps you better organize your code and future-proofs your Three.js projects. If you're interested to learn more about using the Three.js library in your Hype projects, keep an eye out for future videos on the Altered Mindware YouTube channel.